The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you so much for joining today's webinar, Model My Watershed. Today's presenter is Dr. Dave Arscott. He's the Executive Director and Research Scientist at Stroud Water Research. He's also the organization lead for the development of Wiki Watershed, and Model My Watershed is under that umbrella, which we will be talking about today. By the way, I'm Gabby. I'm the Training Associate at Waterkeeper Alliance, and I'll just tell you quickly that we will be saving questions until the end. But if you have any questions about what's going on in the presentation, clarification questions, or technical issues, please feel free to write those questions in the question box or in the chat box. We will also be recording this webinar, and I will be sharing that later along with Dave's slides. You will also be able to email either myself or Dave with questions that didn't get answered or anything that you think of later. So before I turn it over to Dave, we have two quick poll questions, and I'm going to pop those up. First poll question. Have you ever used a simulation model to better understand water quantity or quality conditions in your local waters? And I'm just going to wait a few more seconds for people to answer that. Okay, and here are the results. All right, and then we have one more question. Have you ever used modelmywatershed.org? Okay, and I'm going to close that up. Here are the results. All right, and without further ado, take it away.
Yes, thanks. Just need to share my screen, and I believe everyone's seeing my slideshow, correct, Gabby?
Yep.
Excellent. Well, good afternoon, everyone. Thanks for joining. I think the same folks that answered yes to number one probably answered yes maybe to number two. If you said no to number one and yes to number two, then you probably should have said yes to number one, because Model My Watershed is a simulation model for modeling water quality coming off the landscape that enters our streams, rivers, and other waterways. So today I would like to introduce you all to this freely available online tool and give you a demonstration of how it works. If you have enough screen space, you're welcome to open up your web browser and click along on the application once I go to the live demonstration. Before I get started, I'd just like to share with you that Wiki Watershed and the Model My Watershed web app have been developed by a team of folks from around the country. The Stroud Water Research Center is sort of the lead organizing entity, but we're heavily collaborative and dependent on many different people, from the Academy of Natural Sciences at Drexel University to Limnotech to folks at University of Washington, Utah State, and the software development company in Philadelphia, Azavia. Of course, thanks to Waterkeeper Alliance for hosting the webinar today. And first slide here, just to give those folks some credit that are members of our development team at Stroud Water Research Center, as well as at these other organizations around the country. I didn't mention Millersville or Concord Consortium down at the bottom there. I should have. They're heavily involved with our education team in the development of tools for teachers and students to utilize Model My Watershed in their classrooms. So there is a set of curricula that have been developed for environmental science, STEM teachers in middle and high school. And I can show you where those resources are if you happen to be a teacher joining us today. If If you're new to Stroud Water Research Center, check us out online. There are a lot of different ways you can connect with us, and you can find my credentials there as well as my email. If you have questions, I'll share my email at the end of today's webinar if you'd like to get in touch with me and have specific questions about what you've heard today. The online live resources that we're going to visit are shown here. WikiWatershed.org is an umbrella webpage that has links to many different tools. I talked about Monitor My Watershed and our Enviro DIY do-it-yourself monitoring and sensor stations for water quality monitoring a couple weeks ago in another webinar hosted by Waterkeeper Alliance that I believe is posted online. If you're interested in learning more, you can watch that hour-long introductory webinar. Today I'm going to focus on Model My Watershed, and we'll go there in just a moment. Certainly would like to acknowledge the funders that contributed or helped make this tool available. We've been working on Monitor My Watershed technology for more than 10 years now, and have many different funders to thank for that, from the National Science Foundation to William Penn Foundation to the Stroud Center itself, and a couple other donations and foundations. So what is Wiki Watershed? The overarching umbrella. It's a web toolkit to support citizen scientists, conservation practitioners, researchers, students, educators to collaboratively advance the knowledge and stewardship of our environment and fresh water. Today's webinar goals are going to focus on Model My Watershed. I'm going to highlight the use and the features within this web application. Then we're going to use a couple of the water quality models that are available to scenario build conservation and restoration landscape. I'll also show how you can share your projects, save and share via a third-party resource called HydroShare. And if we have time, I'm going to introduce something called hotspot modeling or subbasin modeling, which is a tool to help you see how certain nutrients, nitrogen, phosphorus, and then sediment may come off the landscape differently in a larger watershed context. And then we'll talk a little bit about future features that we hope to make available in the very near future. So if you go to wikiwatershed.org, you'll see a list of all these different resources. I'm not going to go through each one, but would just like to let you all know that there are a variety of tools that are useful for online learning, water quality monitoring, macroinvertebrate education and monitoring, and general water quality applications. And of course, these tools are often useful in the field or to conduct field work as well. So Model My Watershed, the vision here is to provide an easy to use sort of pro-grade modeling package to inform land use decisions and support conservation practices and watershed education. It is freely available through wikiwatershed.org. When you jump into Model My Watershed, as we'll do momentarily, you'll have access within the continental United States to all of these sorts of data sets in a fairly intuitive and easy to use format. So we have the National Stream Network, air temperature, precipitation estimates, elevation, slope, hydrologic soils, and a variety of other data layers that we'll see. These are the ones that are most informative, most useful for the water quality modeling that can be done within Model My Watershed. What you may not see in a visualization are a couple, oh, and there's a national land cover, sorry about that. Underneath the engine, there are a couple other data layers that help inform the water quality models that I'd just like to share with you quickly. So we do have information flowing into the app that accounts for some base flow estimates. It's an input layer for one of the models. We have groundwater nitrogen estimates. This another layer from the USGS. Soil phosphorus estimates, soil nitrogen estimates, and we have a preloaded grid of weather stations that drive particularly the watershed multi-year model. These are 214 weather stations with daily precipitation and temperature data from 1960 to 1990. So Model My Watershed allows anyone out there to analyze land cover, protected areas, active river area for the Northeast and Mid-Atlantic, soil, hydrologic soil groups, climate elevation slope, animals, and point source data for your area of interest. And there are many different ways to define an area of interest, as you'll see in a moment. There are community tools for saving, sharing, and comparing your work. And there are two primary models that are deployed right now. One is called the Site Storm Model Package, and the other one is the Watershed Multi-Year Model Package. And we've tried to label these to help describe the type of model and the way it can be used. The Site Storm Model is most appropriate for smaller geographic sites, like maybe a square mile and less. It is running some algorithms that take an estimate of precipitation occurring over a 24-hour period and predicting whether that precipitation runs off the landscape, infiltrates into the ground, or is evapotranspired. And then it also is connected to a water quality spreadsheet tool that the EPA has widely available called Spreadsheet Tool for Environmental Pollutants, L. We have detailed technical documentation available in wikiwatershed.org that I'll show you for both these models. The Watershed Multi-Year Model is a model that's more appropriate for a little bit larger scale watershed modeling, and really is an annualized model, although one can develop seasonal, monthly, and weekly statistics from it. But it takes 30 years of daily precipitation and temperature and pushes that through the model and through the landscape and predicts things like the infiltration of water, the runoff, and stream flow and evapotranspiration, as well as nitrogen, phosphorus, and sediment concentrations that come off of that landscape. We have ability to create and compare scenarios of model changes, so you can change land cover and you can implement best management practices or conservation practices to see how the model estimates change as you may be thinking about conservation and restoration activities that you might do on the land. We've recently added a few features. If you've used Model My Watershed in the past, you might check it out again. We have a national coverage layer for protected lands, and we've enabled the Analyze feature. We do that for active river area as well. Within a couple months, we will be adding some other features as well, and I'll come back to that. At this point, I'd like to go right over to Wiki Watershed and give you a demonstration of these tools. So you can go to Wiki Watershed now if you're online, have your web browser open, and explore all of these tools. This is the homepage for wikiwatershed.org. And you'll see Model My Watershed right up here on the left. You could launch the app, or you can first learn more. I just want to click on the Learn More before we launch to let you know that Model My Watershed, there's a little introductory statement here, access to the application, and a learning tool that's called the Runoff Simulation app. There is also help resources here that may be hopefully helpful for you. Visit the help page for Model My Watershed, and you'll find, most importantly, that I use most often is the technical documentation, which will give you very detailed information about everything you can see and do in Model My Watershed. And then there are some general resources, learning tools for the different types of models that are there. And we also post videos like this webinar on wikiwatershed.org, and I believe those occur perhaps under the help. Well, I'll come back to the videos and show you where those are later. So when we launch the app, you click the app and you'll open another web browser, and the geography may zoom in to your local area. Stroud Water Research Center's just outside of Philadelphia, so I'm zoomed into the Northeast US. And you will see a panel on the left here that says select area. Perhaps it might say get started when you first arrive. You'll see a black bar across the top that has a login, and logins are freely available. I just logged into my account, but if you're new to the application, this pop-up will come and you can continue as a guest, or you can register for an account. The Learn portal and the ITSE portal are specific to teachers and classrooms. If you're interested in learning more about those, I'll come back to that at the end of the presentation. If you enter as a guest, you will not be able to save your projects or share your projects. So I'm going to enter with my login. There are a couple other features up here that get to the back end of your account that are important before we get going to understand. So under my account, we'd really appreciate to know a little bit more about you and maybe the type of user that you might be, if you're with an organization, and where you are. And this drop-down in particular may be important for you to toggle your projects between metric and US customary units. You can do that at any time, and all of your saved projects would instantly change to the new unit scheme. The account tab is really for software developers. There's a backend API that can be utilized. I'm not going to talk about that today. And then there's a way to link to a third-party website to export and share your projects, and I'll come back to that later. If you return to the main screen, you'll see Get Started here, and let's just get started after checking out the Layers tab. The Layers tab here allows you to turn on and off all the different data layers. The Delaware River Basin is a high-resolution stream network specific to the Delaware. Under the coverage grid, there is the National Land Cover Map. And if you're wondering what the color key is here, you can click on the information icon and you'll see the different land cover classes. By the way, this is the 2011 National Land Use Land Cover data layer. You can visualize the hydrologic soil groups as I showed in the slideshow to begin with. There's an elevation ramp here and many other data layers to explore. Here's the protected lands data layer that shows the various categories of protected lands. And we have the active river area data, which is primarily the riparian zones around our waterways. Unfortunately, this map is specific to only the Northeast and Mid-Atlantic region. When you zoom out, you can see the maximum extent of that data layer. And then there are observations, and on that observation tab are our weather stations, the national grid of weather stations, the 214 weather stations that we're using. You can click on any one of those dots and see the weather station number, its name, and the time period for the data that we're drawing. This way, if you have interest in finding that weather station on the NOAA website, you could know the number and find those data yourself. Lastly, there's base maps. I need to toggle off the active river area. There are different base maps. Our next release will change somewhat from this base map, but you'll see that we have satellite images here. This is a data layer from Esri. There's satellite with roads, which technically is, I believe, a Google data product, USGS as well, and then a terrain map. So you can choose whichever. The terrain map actually has some contour lines that can be visualized somewhat here. So that's enough for a layers introduction. Let's get started. The workflow path here is to select an area on the map that you're interested in. So I would ask somebody to type in the chat box, hopefully I'll see it, a location, maybe a state and a town that I can go to for the demonstration. And Gabby, if you see something come in, let me know.
Okay.
Anybody?
Yep, we have two. I'll read. The first one is Columbus, Georgia.
Columbus, Georgia. All right. I'm going to use the search box, and we're going to zoom to Columbus, Georgia. And we'll start with that location. I'm going to turn on the streams layer so I can see the different streams a little bit easier. And we could even turn on the hydrologic units, and let's look at a really small hydrologic unit there. And I think I'll select this one. So notice when I toggle this on and off, the red lines come on. This is the HUC 12. If you don't know HUCs, it's the USGS terminology for hydrologic unit code at the 12-digit level. So it's a smallish fragment of a watershed. I'm going to select the boundary using the HUC 12, and when I enable the select boundary tool, as I hover over my HUCs, the name pops up. So we can see that I'm about to click on the Cooper Creek, Bull Creek, HUC 12, and when I click, it will select that HUC and conduct an analyze feature on the underlying geographic information and provide the summary statistics on the left side of your screen. So we have several tabs up the top: streams, land, soil, terrain, climate, point sources, animals, and water quality. I'm going to quickly go through each one of these. The streams are simply the blue lines that you see here quantified. This comes from the USGS's continental US medium resolution stream network. We can turn this on and off right here. And if you want to know a link to the source, you can click into the technical documentation. And you see streams labeled as first to 10th order. If you're new to stream ordering, first orders are the teeniest, tiniest headwater streams. 10th order are the biggest. And so we're getting a summary of the total length of first order streams, second order, third order, and so on. And we're getting an assessment of the mean channel slope that comes from the underlying elevation model that's beneath the maps. We see an estimate that says we have 0.78 miles of these total 54 miles of stream in agriculture and 53% miles in non-agriculture. So we can turn the land cover data on to have a look at what this land cover looks like in that area. And clearly red is mostly developed. There's very little agriculture or forest in this highly urbanized watershed. And you can download those data if you would prefer to get that table as a CSV file that you can open in a spreadsheet. The next one is land cover. So this is a summary of the colors you see on the map right now, and we can also turn this on and off here. You have both a graphical form that's relative percent and a table down below that gives you the area in square miles and percent cover. Notice we're outside of the data layer that has the active river area, but if we were in the Mid-Atlantic or Northeast, you would have the land cover within the active river area in that column. You can download those data, and we can also see the protected lands. And it looks like there are a few pieces of protected lands in this data set, parks or recreation areas locally. And we can see that those areas quantified down below in the table. And then the next table is similar format, but this is the hydrologic soil groups. We can turn these on and off. You can have a table down below. There's a terrain analysis, which looks at the elevation changes. The green is pretty homogeneous because the color codes were used for the entire United States. So it's hard to have a different green for small elevation changes compared to the Rocky Mountains. But you'll get the statistics for elevation in the table below, and you can see the slope map as well, which does show a little bit more of the flat areas and the steep slopes. There's a climate grid that can be visualized, the precipitation data. When you visualize the precipitation data, you'll notice a slider pop up here. And the colors are related to a national color grid, so you might not see a lot of change locally within any month unless you're in an extreme mountainous area. And you can graph either the mean temperature or the mean precipitation as well. Let's see if there's any point sources. There's no point sources in this watershed that are being identified. These data come from the EPA's National Pollution Discharge Elimination System, and is not regularly updated. I believe this is now 3 years old, this data layer. There is a animals data layer, which is mostly estimates of farm animals, and since we don't have much farmland in this geography, we won't be seeing many high density of any of these farm animals. And I'll skim over the water quality app. So that's a quick review of the analyzed information that you can get for any area in the lower 48 United States. You can also run models for any area in the lower 48 states, the site storm model, the watershed multi-year model, or we have a new tool down here called the watershed multi-year worksheet. This last one is the subject for a longer webinar, and I'm not going to touch on the worksheet. The site storm model is, as I mentioned, most appropriate for a smaller area than what we're modeling here. So I'm going to start by using the watershed multi-year model for this particular area. And when we click on that model, the underlying algorithms are taking 30 years of precipitation and temperature and pushing it through a hydrology and water quality model. The model is in its next generation of model names, but previously this model was known as map sheds and has been used largely fairly broadly in the mid-Atlantic region, particularly in Pennsylvania. We have done some calibrations, and there's other details about the model that you might be interested in. I'll come back to. But the model output is segregated into hydrology and water quality. The hydrology tab here starts by showing you stream flow as a total water depth each month of the year. And these are average annual over 30 years of daily water input. So you shouldn't expect that today's stream flow looks like the modeled stream flow, as this is a 30-year average condition that you're seeing here. You can change the graphic to look at surface runoff or any of the other hydrologic components, subsurface flow. Point sources should be 0 because we don't have any point sources, evapotranspiration, and then, of course, the precipitation, which was actually the input data. You can download those data as well. And you can turn on the weather stations used to drive this model. And you may have to zoom out to see those. And I'm trying to find them. I'm seeing that they're not popping up. There they are. They were very subtle. But if you're interested in knowing where the precipitation and temperature data came from, it's a mix. It's an average of that station and the station that was further to the north here. All right. So that you could track down those data if you were curious to look at those raw data. The next tab for modeling this area is the water quality tab. And here we have estimates of sediment, nitrogen, and phosphorus as far as the total load coming out on an annual basis for each of those components. The loading rates normalized per acre, and some estimates of mean annual concentrations of these water quality components, sediment, nitrogen, and phosphorus. And the model distributes those loads into the different land cover classifications that are in your area of interest. If you click on this sediment tab, you would get a ranking of what's the highest input for sediment. For total nitrogen, we have subsurface flow, so groundwater has high nitrogen, and for phosphorus, estimating the stream bank erosion. Please note that the stream bank erosion is largely driven by the impervious surface cover in your watershed, and this really should be viewed as a call to address stormwater coming from impervious surfaces, not necessarily a call to riprap and hardscape all of the stream banks in your watershed. So that's the basic introduction to the watershed multi-year model. There's some other really fun tools here to add changes to this watershed. Over here in the right-hand corner are some words, add changes to this area, and when you click on that, you'll see that a new scenario pops up. You still have the current conditions available to toggle back to if you want to go back to current conditions. But here's the new scenario, and with the dots here, we can rename this, and I'm going to say reforestation and stormwater BMPs. We're going to build a scenario that reforests some parts of this watershed and adds some stormwater BMP. So the first step is under land cover. I am going to add forest. to these 26,000 acres of total land. So we have 3,282, and I'm going to add 1,000 acres of wooded area. So that would be 4282.6. And we are going to say that that was replacing some of the low density open space, which was 6,481.4. So we need to take this down to 5,481.4. The red is telling me that I'm off by a decimal. Wrong way. Okay, so now I'm balanced. You have to have the same amount of area, but you can change any of the land cover components. And when you hit save, the model reruns and updates. So we've added 1,000 acres of forest and debited 1,000 acres of open space developed. Next, we're going to add a conservation practice to some of the urban lands. We're going to put some vegetated buffer strips along our waterways. We had 52 miles of non-agricultural streams where we can add this best management practice. And I'm going to have a goal of addressing 10 of those miles. So that's vegetated buffer strips. And I'm going to put in some infiltration bioretention areas. We have a lot of area here, and one needs to be realistic in how big a infiltration basin might be. But let's say I'm practicing I would like to implement 3 infiltration basins, and each one is going to be an acre, let's say 1.5 acres each. So that would be 4.5 acres. And now I've added the infiltration bioretention. And actually it says 5 acres there, and buffer strips. Now for this whole area, we can see if we made a difference by using the compare function. And we can just see that we're starting to make a change, an estimated change between the current conditions and this scenario that I've built in reducing surface runoff from these 26,000 acres. We've increased subsurface flow a little bit. We didn't do anything to point sources, and we've changed evapotranspiration ever so slightly. And in water quality, we have reduced sediment loads by about, looks like 2 million pounds per year. Nitrogen loads have been reduced, although less so, and the number doesn't change here. But probably in the table with more significant digits, we've had a reduction. And we've reduced phosphorus loads from 9,800 to 9,400 pounds. And of course, you can see these in tabular form or in a table as well. And we can begin to look at how those are apportioned to different land cover types. So that's a quick introduction to the watershed multi-year model and how to build scenarios. You can continue to build new scenarios, and I believe you can compare on these graphs up to 7 different scenarios. You can also share this project. If you're logged in, the project is automatically shared to your Model My Watershed account. But if you'd like to send somebody a link to this project, you can turn on link sharing and just copy the URL and send it to them in an email. They can open it, but they would not be able to edit it. The other one that's HydroShare, I'll come back to if we have time, but this is to connect to a third-party website where you can export your project, share it, and give ownership to somebody else who can then edit it. I'd like to take a moment to go back and do a new project and get another chat box from another location somewhere. Gabby, perhaps you can help if somebody wants to type in their town and state.
We have Greenboro, Maryland.
Greenboro.
Not coming up.
Greenboro, Maryland.
Greensboro, sorry, with an S. Greensboro.
With an F? I'm not hearing that.
S. S is in sister.
Greensboro?
Yes.
There we go. And oh, there we go. All right, turn this off, get familiar with the landscape, turn on the streams. And yeah, this is a smaller area. Let's have a look at the national land cover, how this is classified. Looks like we have some agriculture nearby. We have a little bit of urban landscape in town, some forested land. All right, so this time I am going to draw my own area using the free draw tool, and I'm going to draw it small enough to use the site storm model most appropriately. So let's say I had a project that was along this road, and I had the opportunity to work with this landowner that might be in between these two creeks, not knowing that you have such a landowner there, but we'll just use the roads underneath and double click to close. Once you close the polygon, you've selected that area and you're performing the analyze function. And you get the same statistics that come out here. I've got mostly cultivated crops and developed open space, low intensity, red over here, medium intensity, etc. This time I'm going to run the site storm model, and the site storm model takes a rain event and puts it down over 24 hours on this landscape and predicts the evapotranspiration, the runoff, and the infiltration that occurs. But you'll notice here you get to choose what the precipitation intensity is. So I don't know, maybe that person who put in the chat box knows what a 2-year storm event is. And Gabby, if that comes in, let me know. But up in Philadelphia area, 2-year storm event is about 3.3 inches. So I'm going to use that. And we're going to put it at 3.3 inches. So you can use that slider to put, I believe, up to 10 inches over a 24-hour period. And this is a little bit more simple output. On the water quality side, we have total suspended solids, total nitrogen, total phosphorus. We don't have this apportioned to the exact land cover here, but you can see the loads and the loading rates coming off this integrated landscape. We can also add changes to this area. It's a little bit different than the watershed multi-year model. It's actually a little more fun, and it's designed to encourage young folks to play around with this as well. We use this in the classroom quite a bit. You can name your scenario. We'll rename, we'll do ag BMP. And we will, let's see, take some of this land cover and put no-till agriculture on the portions of the farmland. So first step is to say, hey, maybe this individual's already doing no-till, but if they're not, then we can get an estimate of what might happen if they implement no-till ag. And notice here we had to draw a polygon roughly over the farm field. And we can see the area of that polygon and that we've assigned it to be no-till ag. So unfortunately, you'll see that there are fewer BMPs here than in the watershed multi-year model. We hope to expand those BMPs in the future. But we can also zoom in here to this particular location, and we could consider putting in a vegetated infiltration basin at the edge of that property near the cemetery. And this is a challenge to draw this to scale. I'm not sure exactly how large I'm drawing that, but once we, so we see this as a 14,000 square foot BMP. We could ask this landowner to put their parking lot in a porous paving. So let's pretend this is their parking lot. The other options here are rain garden. Maybe we convince them to put a green roof on top of their business. And now we have these 4 modifications in here. And of course, the model updates instantaneously and we can see the results here, but the results don't have a lot of context until we use the compare function. And so now we get to see the hydrology side by side where we've reduced the runoff, we've increased the infiltration, and our water quality has been reduced or improved as well. Total suspended solids were reduced, nitrogen and phosphorus. With the site storm model, we automatically calculate a predominantly forested area. And so that's replacing all of the ag and urban landscapes with predominantly forest. So this would have been like a pre-colonial, pre-Columbian estimate if that landscape was entirely forested. You can also move the slider bar for precipitation here on the fly. And clearly at some point with incredibly intense storm events, you know, the differences in our best management practices become less of a contrast. Okay, those were a couple of the scenarios and modeling tools that I wanted to show you. How are we doing on time? We have about 10 minutes to go, and I'll save it about 5 minutes for questions. A couple other features that I'd like to share with you all. Let's go back to my account and linked accounts and see how mine says HydroShare linked. I just want to share with you what HydroShare is. hydroshare.org. This is a resource that's been developed by the Consortium of Universities for the Advancement of Hydrologic Sciences, or QUASI. It is a data repository and is freely available. So you can sign in for your own registration. And once you do that, you will have the ability to link your account in Model My Watershed. And under this part of Model My Watershed, you would come in and type your username and password and link your account. And once you do that, it's a one-time process. You now have the ability to share your projects to HydroShare. So I've already done that, and I'll show you how that works. Number one, I'll show you that indeed the project that we did first for Cooper Creek is automatically saved under my projects list. And even though I didn't name it, Again, I could share this with the URL right here, or from this point, I can click HydroShare Export On, and we can then type in a title, Cooper's Creek, Georgia test. Both the title and the abstract are required, and the keyword is optional. And when you click export, you'll see a little wheel turn here, and Model My Watershed is sending that project information to HydroShare. And when this is finished, it will appear in HydroShare under your account. So you can click to My Resources, and you should get a list of all of the projects that you've shared. And by the way, you can use HydroShare to upload other data as well. If you want to use it as a repository for your water quality information or other GIS data and make that shareable and archivable, the resource is there for you to use. You'll see that right now it's tagged as private, and that's primarily because Model My Watershed is still sharing that project. It takes a little while to send the data, but once it does finish, it tells you that it's exported it. So if I refresh over here, the red has turned green. Please note that when you share on HydroShare, your project is instantly public, but you can make it private, but the default is public. And when we click on Cooper's Creek, we go in and see the metadata about the project. We can see its general location. We can see that it's Model My Watershed, that David Arscott sent it here. And we can see some of our data down at the bottom and the contents. All right, particularly the area of interest GeoJSON. There looks like there was a hiccup in sending some of the data because there should also be modeling results in here. Once you've done that, you can share and manage who has access to this, and they should be able to open it in Model My Watershed with the open with. All right, that was a quick look at that feature. I want to draw your attention to a few other things before we move on. First, our development of Model My Watershed, like many of our other Wiki Watershed projects, are as open and freely available as possible. We have all of our development teams sharing as much of the code and the resources as possible and making documentation of those. So GitHub is a repository for code data, and we have a Wiki Watershed GitHub. And under that, there is a Model My Watershed, where you can find very detailed information about the development of the software. It might be beyond this webinar to talk about how the software is working, but we have very strong transparency on the software development side. So that was number one. Number two, I'd like to share the help resource to show you where you can find out more information that may answer most of your questions that you may be thinking about. We'll go back to the View Help Resources, and in particular, the technical documentation under Model My Watershed. This is a fairly detailed account of the entire process, the workflow that I've just showed you, from the understanding your account page to getting, hey, what are these data layers and where did you guys get them from, right? So we tell you exactly which data layer was utilized and embedded in Model My Watershed, and how you could go and find the source data yourself if you're a GIS user or just want to see the raw data. We show you how to select your area of interest and how Analyze area of interest works. And probably most importantly, we have strong documentation of the source and source codes for the modeling algorithms. And I'll just quickly show you in the watershed multi-year model. I usually get this question at the end about calibrations and appropriateness of use for the model. We have not calibrated it for every single geography in the United States. But there has been some work in model calibration. These basically USGS gauging station data where there's nitrogen, phosphorus, and sediment have been used to help calibrate the model. You can see the geography. This is an area that we are working on and improving, but just wanted to share with you that. Go ahead and type in some questions to the chat box, and while you're doing that, I will just say that we continue to work on upgrades and updates, and there's so much more to share with you all. I could get lost in this for hours. I have fun. Hopefully you've had fun. In the next couple months, we will be adding the functionality so you could upload your own climate data. This would require daily temperature and precip for a 10-year period. We're also going to automate the upload of future climate scenario modeling for the Delaware River Basin. We've been working with colleagues at Shippensburg University and Academy of Natural Sciences to work with global climate model downscale data to process that for the Delaware and make it available for scenario modeling out to the year 2100 for both medium and high emissions scenarios from the climate models. We've been working with those same collaborators, Shippensburg and University, Claire Jansen, Tim Hawkins there, and colleagues at the Academy of Natural Sciences, Lynn Perez and Barry Evans, to implement a development scenario that Shippensburg had produced out to the year 2100, estimating where development may occur given smart growth and sort of unconstrained growth in urban environments. And lastly, we're working hard to find funding to update the national land cover to 2016. And I hope that's done by the year end, but will be dependent on funding. Okay, Gabby, is there any questions that came in?
There is a comment, excellent webinar and resource. Thank you for the information. I plan to start using this cool toolkit as soon as possible. And then we have another question. I'm not sure exactly what the person is asking. I'll read it and we'll see. Question is the rainfall period of record that ended in 1990 still valid?
Well, it's absolutely valid as historical data point and as a an estimate of climate at one point in time. I think we've all recognized that changes in local meteorology are a little bit different than climate, and really we need to be thinking about decadal periods when we take meteorological information and talk about climate change. So I think you're probably all aware that over decadal times in the last 50 years, we have experienced change, and that change is different depending on where you are. Here in our part of Pennsylvania, we're getting a little bit wetter and a few more high intensity storm events. So those 1960 to 1990 data are becoming a little outdated, but I wouldn't say that they are misrepresenting today's reality. It's a 30-year average. These are average conditions. And yes, we may expect that there might be a little bit more water on an annual basis, which would translate into likely higher sediment loads, more nitrogen leaching, and greater phosphorus loads. So that's why we're enabling the custom climate upload, so that if you have a data set that's more close to present day, you could add that to your project. And that's why we're working, at least within the Delaware River Basin, to put future climate scenarios at the fingertips of folks in our geography. That's a great question. Thank you.
Okay, thank you so much. This was so informative. It looks like we're just out of time, and we don't have any other questions coming in right now. But as a reminder, I'll be sending around these slides and this recording, so you can feel free to either email myself or Dave if you think of any questions. So
Yeah, and you
thank you
can
so much.
see my email down at the bottom there. Thank you so much to everyone for attending, and thanks to Waterkeeper again for hosting.
Yes, and thank you. This was fantastic. All right. Bye.
Bye-bye, everyone. Stay safe.